again, welcome back to my YouTube channel. This is Unit 2 Current Electricity, and we are discussing the various topics of this unit. In the previous lecture, we have talked about the grouping of cells, but in this part we are going to talk about the Kirchhoff's rules. We are having two Kirchhoff's rules, and we have to implement these rules in order to solve the various numerical problems. Although I am going to state these laws, but still we need to implement these laws in order to solve the various numericals. So let us talk about the first rule, which is called a junction rule. According to Kirchhoff's junction rule, the sum of currents entering the junction point is equal to sum of currents leaving the junction point. Let us say we are having I1 current, I2 current, I3 current and I4 current, such that all these four currents are entering the point A, and we are having three currents, that is I5 current, I6 current and I7 current, which are leaving the point A, junction point A. Then according to Kirchhoff's first rule, that is junction rule, we have I1 plus I2 plus I3 plus I4 is equal to I5 plus I6 plus I7. So that means we can also say that the sum of currents entering the junction point and leaving the junction point is 0. That means we can say that total current entering and leaving the junction point is 0. This law is based on the law of conservation of charge, as the amount of charge meeting at a junction point is 0, because the amount of charge which is entering at that point is equal to amount of charge which is leaving that point. So in an electrical circuit, at a junction point, the number of currents entering at a junction point is equal to number of currents leaving the junction point. So this is the first rule. And second rule of Kirchhoff, which we call the Kirchhoff's loop rule. In this rule, we say that if we are having a electrical circuit which is a closed electrical circuit, such that there are various sources of EMFs connected in this circuit, and we are having number of resistors through which different currents are flowing, then in this case we can say, according to this second rule, that the sum of all the EMFs which are present in the circuit is equal to sum of product of resistances and their respective currents flowing through them. That is, summation of E is equal to summation of I into R. So this is the Kirchhoff's second rule, but still these are the statements, and we need to know how to apply these statements, so that we must be able to solve the various numerical problems. That means we need to take some of the sign conventions. Today we are going to learn about these sign conventions, and in order to learn these sign conventions, we will have to consider a circuit diagram. So let us say we are having a circuit diagram such that from A point to B point, we are having a resistance R1 connected between these 2 points. So R1 is the resistor from A to B, and then we are having second branch B to C, such that R2 resistor is connected in branch BC. Then we will form another branch C to D, such that in the branch C to D we are having a cell of EMF E1, such that its negative terminal is connected to C end and its positive terminal is connected to D end, but this positive terminal is firstly connected to the resistor R1, and the second end of the resistor R1 is connected to the D end. Now we are left with one more branch, that is, we are going to join D to A, but in this branch we are going to keep one more resistor of resistance R4. That is, one end of resistor R4 is attached to D end, and the other end of resistance R4 is connected to the positive terminal of the cell E2. That is, the cell is having an EMF E2, and negative terminal of the cell E2 is connected to the A end. So now this loop is completed. From this loop we are going to learn how to apply Kirchhoff's loop rule. So in this loop, let us say we are having E1 cell, that is a cell of EMF E1. So we know current starts flowing from the positive terminal of the battery and it goes to the negative terminal of the battery. So definitely this EMF E1 is going to send I1 current through resistor R1 from direction C to D. So let us say I3 current is passing through the resistor R3, and therefore the direction of current will be marked towards D. When we will look at the branch AD, so in AD branch we are having a cell of EMF E2 such that this cell will also send out its current from the positive terminal. So that means from E2 EMF, the current is flowing I4, and this I4 current is passing through the resistor R4, and this I4 current will flow from A to D direction. Now assuming that I3 current was greater than I4 current, therefore net current which will enter from A to B will be in the direction A to B. So as in the arm AB we are having a resistor R1, let us assume that I1 current is flowing from branch AB. Then from branch B to C we are having I2 current flowing through resistor R2. Now in order to apply the Kirchhoff's rule, we will have to consider a loop. So I will consider a loop A, B, C, D, A. So when we talk that we are going to consider a loop, then in that case, the point from where we are starting, we have to end at that point, right? So our loop is A, B, C, D, A, and now we are marking the loop from A to A. So this is our loop. Now we are moving from A to B. So your current I1 is flowing through the resistor R1. We will write on the left hand side that I1 R1. So the sign will be positive. Why the sign will be positive? Because we are moving from A to B, and I1 current is also flowing from A to B. So we have I1 R1. Then we are moving from B to C. Then from B to C we are having a resistor R2, and from R2 resistor I2 current is flowing, right? So if I2 current is flowing through R2, that means we are also moving from B to C, and I2 current is also moving from B to C. So direction of loop is same as the direction of current. Therefore we will say that plus I2 R2. Right, so that means on the left hand side we are having I1 R1 plus I2 R2. If there will be no resistor in B to C loop, but I2 current is flowing through BC, but there is no resistor, in that case we will write 0. So we can write I1 R1 or I2 R2 only in that case when we are having a current flowing through a resistor. If there is no resistor in a loop, then we will mark it as 0. Then we are moving from branch C to D. Now we are facing a cell having EMF E1. And if this is the case that we are facing the cell of EMF E1 such that we are first coming across the negative terminal, then on the right hand side we will write on the right hand side of the equation. First of all, we have already written I1 R1 plus I2 R2. After leaving some space so that we can write various other terms, we will put a sign is equal to, we will leave the space before is equal to, and after is equal to we will write plus E1. Why I am writing plus E1? Because while moving from the loop C to D, while moving from the branch C to D, at that time I am facing negative terminal first. So second terminal is positive terminal. So the sign of second terminal is taken into consideration, that is plus sign. Plus sign is placed at the second number when moving from C to D. Therefore we will write plus E1. Now we are having R3 resistor in the branch C to D. If there is a R3 resistor in branch C to D, our loop is moving from C to D and current I3 is also moving from loop C to D. Therefore, we can say it is a positive product, that is plus I3 R3. So we will write plus I3 R3 in the left hand side of the equation, right? Now we have to move from D to A. We are moving from D to A. I4 current is coming from A to D. That is in the opposite direction. If I4 current is coming in the opposite direction, the direction of loop is D to A, but current is coming from A to D. That is why we will write that minus I4 R4. Although I4 current is flowing through resistor R4, therefore I4 R4 is there. But why I have taken the negative sign? Because current is flowing in the direction opposite to the direction of loop. The direction of loop is D to A, but current is flowing from A to D. Therefore minus I4 R4, but we are having is equal to sign now, and now we are encountering the other cell of EMF E2. While moving from D to A, the first phase which we are encountering is the positive terminal of cell E2. But we always take the sign which is associated with the second terminal. So the second terminal while moving from D to A is negative terminal. Therefore, on the other side of the equal sign, we will write minus of E2. So therefore, by applying Kirchhoff's loop rule, we are having the equation I1 R1 plus I2 R2 plus I3 R3 minus I4 R4 is equal to E1 minus E2. So these are the sign conventions which we take while applying the Kirchhoff's rule. So now I am going to make one circuit so that you can practice applying Kirchhoff's rule on this circuit. Pause the video, check this circuit out, and you have to practice.